Hello, my name is Andrea Frittoli. I'm a developer advocate at IBM. And today I'm going to talk to you about scaling pipelines with Tekton. After a brief introduction, we'll present scaling pipelines both from an authoring and a running point of view. We'll identify a few bottlenecks, draw some conclusion, and at the end of the talk there will be some time for Q&A. But let's start with an introduction. Tekton is an open source project. It's a framework for creating CI/CD systems and pipelines and tasks that can run in a cloud-native environment. Tekton aims for maximum flexibility. It's non-opinionated and it gives workflow authors the full flexibility to define their pipelines the way they prefer. So Tekton is made of actually a combination of projects. Pipeline and triggers are the core components. We have toolings like the CLI called TKN, a nice dashboard, and an operator to manage the installation and upgrades of Tekton. For discovery of tasks, we have catalog and hub. We'll discuss about them later, more details. And we also have several add-ons like the results project, chains, and multiple experiments that we are running. A bit of history. Tekton originally comes from the Knative ecosystem where it was called Build. It later evolved into Pipeline. And finally, it moved to its own project called Tekton and became one of the founding members of the Continuous Delivery Foundation. So Tekton works by extending the Kubernetes API with what are called custom resource definitions or CRDs, which are kind of abstractions that can run in Kubernetes. Tekton defines a few. For the static structure of the pipeline, it introduces the concept of task, which is a combination of sequential steps, and a pipeline, which is a combination of serial, sequential, or parallel tasks. It introduces some concepts like workspaces, as well as parameters and results, which are used as inputs and outputs of tasks and pipelines. Finally, it introduces some resources for the runtime. So task runs for the execution of tasks and pipeline runs for the execution of pipelines. So let's dive into authoring with Tekton. So let's say that you want to automate a certain task. You will use with Tekton some steps. Steps are basically off-the-shelf containers, container images that you can announce with small scripts in any programming language that you might find useful. And then a task is a sequence of such steps that solve a specific problem, like running unit tests against a repository or building a container image or deploying an artifact somewhere. So if you work as part of a team in an open source project or in a large organization, then it makes sense for this task to be shared across the organization, which allows to distribute the maintenance work on this task. So it allows to scale the work of writing and maintaining the task so that each team does not have to rewrite their own and reinvent the wheel continuously. So, but for this reusability to really work, there are a few things that are required. First, the ability to discover tasks, then versioning, and best practices are very important as well. So in terms of discovery, Tekton provides a few options. Tasks can be installed in a Kubernetes cluster and can be run directly from the cluster there, and that's a way to distribute tasks to different teams, install them in the cluster that they use. The community maintains a catalog of tasks which solve a number of common typical use cases like building container images, cloning repositories, and running different tools that are typical in the DevOps area. These tasks are not only stored in Git, in catalog, but they are also searchable both from via a web UI called Tekton Hub, as well as via an API, which allows then integration with the Tekton CLI, for instance, for searching, Hub for tasks, or installing them directly into your cluster from the catalog. In terms of versioning, there are a couple of options. So the approach that Tekton catalog takes is to have tasks stored in different folders so that you have a new folder, a new version. However, when the task is then installed in the cluster, you lose this information. This is because the reason for which we introduced Tekton bundles. Tekton bundles allows you to store tasks as attachment in a container registry and to consume them directly from there, from the Tekton controller. So as tasks are installed, stored in a container registry, then they can be referred to using a tag or a SHA, exactly the same as container images. And we also have a nice integration with TKN, which is a Tekton CLI with a bundle command that allows to create bundles by using the push command or retrieving them via the list. In terms of best practices, we have documentation in the Tekton catalog on how to write your tasks. It's very important to use input parameters and results to declare the inputs and the outputs of your tasks, as well as to use workspaces to share data between different tasks, or as well to inject secrets or config maps into your tasks. One aspect to keep in mind as well is portability. This is an area that we are also still exploring, because we do have support for multiple architectures for Tekton, for running the Tekton controller on top of different architectures. But it's important as well to have tasks that use container images and that include scripts which can be run against multiple architectures. And you may remember when we introduced Tekton that we talked about tasks, but also about pipelines. Pipelines are a combination of tasks that can be run sequentially or in parallel. But can pipeline be reused or shared? Well, if you think of a short pipelines, like the one highlighted in green, you might have very common sequence where you clone a repository, you build a container image out of it, maybe you sign it, and then you push it to a container registry. And this kind of pipeline can be used as a reusable block. And you could use some things like conditionals that are supported by Tekton, or optional inputs to make this pipeline even more portable. If you look at this picture, for instance, the clone build push pipeline is great, but in this case, you might only want to have build and push because you want to clone the repo once and then use it to run multiple things like build and push and test. So having a conditional there would help. For large pipelines, however, it gets more difficult, because if you define a very large pipeline and you want people to reuse it, what happens if they need to add a branch to it, if they need to swap a block, maybe instead of running tests, they want to run a different type of test than the one that is defined there. And how you deal with access control. Different tasks in your pipeline may need to have access to different resources, and how you distribute a pipeline. So as I said, you might have teams that are responsible for environments which are touched by different parts of your pipeline. They might need to run in different namespaces or even in different clusters, or through different platforms. Maybe some part of your pipeline is in Tekton, but maybe you have other part of the pipeline that maybe already run in other platforms. So it's a good idea to break down then your pipeline in multiple pieces. And you can have small pipelines like the one that I mentioned, clone, build, and push. And then every team can own the pipeline they're responsible to. But then you still want to have one workflow. So how can you achieve that? So we have one experimental feature which allows you to run pipelines in pipelines. So you can have a pipelines where you trigger sub-pipelines, basically, and that is a way to compose the pipelines together. Another option is cloud events, which basically would allow you to trigger pipelines asynchronously. And this takes us to the next part of the presentation, where we talk about running pipelines with Tekton. And you may start your pipeline by hand or creating a task run or a pipeline run, but usually you will want to run your pipeline as a result of an event. And so this is where the triggers project comes into play. It basically allows you to run pipeline runs or task runs as a response to events which are transported via HTTP. An example of events could be a pull request, or an image was published to container registry, or something was stored in an object storage. So triggers has several components: the event listener, which is basically the sink that receives the events; filters or interceptors that allows you to define rules on whether to accept or not accept the events, and maybe alter or add something to the body; and then binding and templates, which allow you to extract information from the binding and then inject them into the resources through the templates, so the resources that you're going to create, so pipeline runs. Tekton is also able to generate events, both Kubernetes events and cloud events, which are generated when a pipeline or a task is started, it starts running, or it stops. So now that we discussed our input and outputs of events capabilities in Tekton, let's have a look at our initial pipeline again. We could split it down in a kind of composite workflow that allows for separate ownership of the different parts. So you could have a team that handles the production environment, that takes care of the pipeline on the right-hand side, which is using Tekton as a platform. And then you could have a team, a QA team, which is responsible for tests running on the staging environment. And they might want to add tests, more tests dynamically. And they can do that now if they listen to the cloud events generated by the initial pipeline. They can add more tests without having to change the overall pipeline. They just need to have more triggers, so to say, that allow to trigger different tests. So breaking down the pipeline might help with the reusability of pipelines, and it allows also for heterogeneous parts to work together. Still, there are some issues in this kind of setup. One is the kind of the overall visibility on the flow of the workflow of the pipeline. At the moment it's broken down and different parts are integrated through events. You will need some tooling to be able to see what's going on from the beginning to the end of your overall workflow, which might be going across different platforms. And the other issue is that because you might have different platforms, they may understand different kind of events. So you may have Tekton generating a cloud event with a certain payload, then you need to make sure that Tekton or Jenkins understand that payload and understand what these events are about. To solve this kind of problems, the special interest group was created in the CDF called events in CI/CD, that aims to define the standard format for these events in the CI/CD space. So in terms of then scaling pipelines while we run them, what are the bottlenecks that we encountered? Well, one might think about very large pipelines. A pipeline is a directed acyclic graph, and you could have a very large one if you don't split it down like discussed. And I've seen examples of pipelines with hundreds of nodes that might be densely connected. So is this a scale issue? Because of the Kubernetes nature of Tekton, because Tekton runs on top of Kubernetes, resources are reconciled, which means that every time a reconcile happens, the DAG needs to be recalculated And if you have hundreds of nodes in connection, that could be computationally heavy. But in fact, it is not, and it does not pose a scale issue. So we had some issue in the beginning, but we optimized the code for building the DAG. And now we are happily running very large pipelines with no significant overhead. Very large pipelines still pose like maintainability issues. And there is one scale aspect that needs to be taken into account, is that task usually corresponds to a pod in Kubernetes. And there is some setup work involved in creating a pod, which means that if you have a pipeline with hundreds of tasks, you will have hundreds of pods, and this overhead is multiplied by 100. So the other aspect of scale at runtime is running many pipelines in parallel. And there are a few things that Tekton does here to make sure we don't run into scaling issues. First of all, API calls are the Kubernetes API are cached. So we use informers everywhere to make sure we don't get rate limited by the Kubernetes API. Secondly, we allow for scaling up all of our controllers. We use a mechanism called leader election. So even for cases where, like the Tekton controller, there are resources that needs to be reconciled, we can scale up and have multiple instances of the controller, and they will not step on each other, and they are able to share the load. In terms of utilization of cluster resources, when we have multiple pipeline running in parallel, we rely on the Kubernetes scheduler. So things that could be done, and we have done, I think, are like throttling the number of pipelines that you execute. This is not supported natively by Tekton, but it can be implemented. Also, it is possible to optimize the execution runtime, so the way that tasks are mapped into pods. If we make that optimal, we can reduce the amount of resources used by the cluster, and then scale better when we have very large pipelines or many pipelines running in parallel. An option that we also consider is writing a custom scheduler for Tekton that would be optimized to the way Tekton utilizes Kubernetes resources. In practice, we use Tekton for Tekton-owned CI/CD. So we run thousands of tasks a month in this kind of environment. We also run a service at IBM on top of Tekton. Tekton is a service which runs millions of containers per month with no issue at all. In that kind of environment, we use throttling as well as upstream. And for security too, we don't want to allow people creating pipelines without any limitation. And another issue that we see when running multiple pipelines is cluster pollution, where multiple resources are created. So the history of the execution history stays on the cluster, and that creates problems over time. And that's for these reasons, we created a Tekton results project, which allows to store the execution history of cluster, and eventually it will allow to clean up resources as well once they are stored in the database of cluster. So to conclude, we have seen scalability aspect from offering point of view, and runtime point of view. It's important at author time to follow best practices to make sure that tasks and pipelines are reusable. Versioning is key for sharing the tasks, and it really helps to break down large pipelines into small parts that can be then reused, and then those small pipelines can be recombined together to make the whole workflow. From a runtime point of view, it's very good news. Tekton is cloud native, and it's kind of scalable by nature. Things that can help to solve some specific problems that we've identified are execution throttling that can be used to limit number of pipelines running in parallel, as well as we are working on optimization from the runtime to resolve the issue with the pod creation overhead. So in terms of roadmap, from a scaling point of view, well, we continue to dog food Tekton, so to run Tekton at scale to CI/CD Tekton itself. And we have a few features that we are working on, like pipelines in pipelines that I mentioned. There is step 60, which is for remote resource resolution, which the idea is to extend the concept of OCI bundles and allow tasks to be stored and shared through arbitrary mechanism. We are working on optimizing the execution of combination of tasks through the decoupled task composition and scheduling. As well as we want to make bundle more powerful by allowing to define which bundles needs to be used at runtime as opposed to author time as it is today. Also, we plan on Tekton side to implement the cloud event format defined by the SIG events when it becomes available. So thank you for listening to the presentation today, and we'll have some time for questions in a moment. So this presentation itself is available on GitHub. Here is the link to the slides. And please come and join us at Tekton. We are a very welcoming community and we're looking for contributions. Here are some links that might be helpful. And thank you again for listening today. Bye. Hello, everyone. Hopefully you can hear me. So if you have any more questions, please ask them in the Q&A, and I will start going through some of the questions that were asked during the presentation. And so the first question was steps must run in parallel. Yes, so that's the model Tekton takes. Within a task, your steps are implemented as different containers in a pod, and they are executed in sequence. So they cannot run in parallel, but we do support having a sidecar, so you could have a parallel container that runs through your task. And there was a question about where to learn more about Tekton. So we do have some scenarios that you can run, Katacoda scenarios from the tekton.dev website, as well as we have the documentation from all the projects hosted on the website as well. And if you dig into the different repositories like Tekton CD pipelines, we have examples that we use for testing, but you can also use them for reference when writing your pipelines. Other good sources of inspiration if you're writing your own task or pipelines are, of course, the Tekton catalog itself, where you can look into existing tasks and you can browse them through the hub, which is hub. I'll just put it in the chat. We also dog food Tekton, so we use Tekton to build and test and release Tekton itself. So we have a repository, Tekton CD/plumbing, where you can see the Tekton resource that I used for this, for building and releasing Tekton. Okay, so Tekton and OpenShift. So there is OpenShift pipelines is a distribution of Tekton that you can find on top of OpenShift. And Tekton versus Jenkins Kubernetes plugin. So the Kubernetes plugin in Jenkins, as far as I remember, allows you to run to get Kubernetes pods as nodes for your Jenkins execution. So if you combine it with other plugins and like pipelines or pipe configuration as code, you could do similar things. But of course, Tekton is born in the Kubernetes ecosystem. It works as an operator. And I think a great advantage of Tekton, or at least one of the things where it tries to excel, is reusability and having a catalog of tasks that you can pick and reuse without starting from scratch. There was one question about different way of cloning your repository, and absolutely yes. So the cloning can be done through one of the tasks available in the catalog, but if you have a different type of technology that you're using for versioning of your code, you can write a new task and you can even share it to the catalog so that other people may use it. How big has Tekton been tested? So in upstream, we run about the order of thousands of tasks per month. I know at IBM, we have a hosted Tekton as a service, and we run the order of millions. That works pretty well. There are other public offerings like relay.sh from Puppet that I know about. I don't know the scale numbers for that, but if you have interesting scale stories about Tekton, I would be really happy to hear about those. There was a question about DAG. Could you elaborate a bit more on the DAG you mentioned? How do you calculate them, and what do you actually use the DAGs for? Okay, that's a great question. Thanks, Emil. So within a pipeline, we have tasks, and tasks by default, they will be run all in parallel at once. But you may use inputs and outputs that we call parameters for inputs and results for outputs to create dependencies between tasks. So you could say, for instance, that certain task emits an output, and then that output is used as an input to another task. Or you can define specific dependencies between tasks as well. So you can say this task should only run after this other task has been executed. And so what the Tekton controller does, it takes all this either implicit relationship between inputs and outputs or explicit, and puts them together, and it builds a graph directed, a cyclic graph, so DAG. And it uses that basically to schedule the task. So every time a reconcile cycle is executed, it looks at the current status of running tasks, and if there is any new task that could be started from the DAG. I hope that's answer. And there was another question about, would you also see pipelines as DAGs? Yeah, so the way we implemented pipelines as pipelines, experimental for now, is to consider a pipeline as a specific type of task, and we use concept of custom tasks. So in that sense, a pipeline also exposes results, and you could have the same kind of relationship between the pipeline task and other tasks. And so the pipeline in a pipeline will become part of the DAG. There is a question from Krishna: does ArgoCD compete with Tekton? I wouldn't say so. Actually, they are often combined together. So you could use, for instance, Tekton to run a build or a CI job, and then use it to trigger a deployment via ArgoCD. Or you could use ArgoCD to synchronize Tekton resources on your cluster. So there are different ways you can combine them together. One of the things that is characteristic of Tekton is that it's very non-opinionated. So it's pretty vanilla. It allows you to create your task and the pipelines in any way you want, and build your workflows in any way you want. Other solutions have a more opinionated approach that can fit or not fit what you need. And because of that, it's often the case that organization will combine multiple solutions. So we'll use Argo for some part of their workflow, maybe Tekton somewhere else, maybe Jenkins or Flux or Captain, or yeah, you name it. So there is a question from Adam: when restarting the pipeline from a point when it failed, will it be implemented? Our devs would love it because after the fixed code issue, they need to run the whole pipeline when it fails? This is a very great question, Adam. In fact, it's a question that we are discussing a lot in the community. There is a tab, we call it Tekton Enhancement Proposal, about being able to rerun a single task within a pipeline when it failed. But yeah, we also discussed about the whole concept of restarting a pipeline from a failure. It may require some snapshotting functionality, or it may not, depending on how deep we go with the implementation, but it's definitely something that we are interested into. And you or your team would be very welcome, of course, if you want to join the community and share your use cases. You can do that joining the working groups, or create a GitHub discussion, or comment on existing tabs in the Tekton CD community repo. Let me just send the link in the chat. And that link, by the way, is also a very good resource at Tekton CD community to find all the resources about how to communicate with the community, join the Slack, join the distribution list, and so forth. So there was another question by King. How granular is the scaling? If you have multiple pipelines for different teams, is it possible to cap the scaling for each team, for instance? Right. So right now, what Tekton out of the box does, it gives you the possibility to start pipelines running right away, or to start them in pending mode. And if you start them in pending mode, you can have an external component that will take decisions about when they can start actually run. And in that way, you can control the amount of pipelines that you can run in a specific namespace, for instance, or in a specific cluster, depending on your needs. I hope that answers your question. There was a comment from Emil. Probably Argo workflow is more similar to Tekton, right? Yes, indeed, I would say there are more similarities between Argo workflow and Tekton than ArgoCD. So there are several similarities. Argo workflow uses YAML to define similar concepts. There are actually some nice YouTube videos I think you can find on with comparison features between Argo workflow and Tekton. Okay. I hope I covered all of the questions that were asked so far. If you have any more questions, feel free to reach out on Slack. I'm often on the Tekton Slack, and also in the slides are available, and in the slides I included a lot of links on how to connect to Tekton and myself. There is one more question. Maybe running CI operation on Kubernetes could be challenging. Many test tools like Mocha and Jest for JS parallelized test run based on pro CPU info number. Within the pod, this file contains the node values, which would cause over parallelism. Have you guys encountered this issue? That's a very good question. I don't have an answer for that. I have not encountered this issue myself, but I would invite you to, if you will, open a GitHub discussion on the Tekton GitHub, and we could continue the conversation from there. And yeah, thanks again for joining the session. And yeah, have a great conference, everyone. Bye.